Read me that problem.
Like
It's like
the
7x squared. Yeah.
7x squared plus 13x plus 5 equals 0.
Okay. So what it wants us to do is never do, like if I divide by 7, I'm not going to like calculate the fraction. You'll see how this goes as we go. But so the first thing we want to do is we're going to just divide both sides by 7, which is the same. It's going to be like this, right?
Mm-hmm. Yeah.
So that makes this just. Why don't you guys just go ahead and copy what I'm doing? You're going to do it again without me, just so you know.
Okay.
So, yeah.
Okay.
Cool. So then if we were completing the square, that thing we usually do is just get this off this side. So we're going to subtract that from both sides. Which takes us to...
Good.
And actually, let me write this way. There's, like, that's b, right? When we complete the square thingy. So the way that we find that amount that we're going to add to both sides, you guys remember what we do when we complete that square?
You take half and you square it?
Exactly. So we got to figure out what half of this is. Really, the simplest way to make cut a fraction in half is to multiply it by half. You can divide it by 2, but then it's like a big mess, right? That's ugly. It still gives you the same thing. So then we can take that, square it. So what that is going to give us is 13 over 7 times 2 times 13 over 7 times 2. And that's going to simplify to 13 squared over 7 squared times 2 squared. Now our problem has told us not to do stuff like turn that into 169 and not turn that into 49. But 2 wasn't one of these original numbers, and we can switch this to 4. It's okay. No big deal. We could leave it 2 squared also. So this is that number that's going to get added to both sides. Okay. So, got to add that to both sides. Okay, so then we know what happens with this from all those drills you did. Oh, you don't do that. What's this going to give me?
X equals.
No. No, I'm just doing that thing like this. What's going to go here?
When you put 13 over 7,
Mm-hmm.
I mean 13 squared over 7 squared times 4.
No. It's
You put
half
of.
It's half
13.
of that, but not half of that squared.
Oh, so just 13 over 7 times 2.
That's right. So we'll just leave. We could simplify this side right now. It's not a bad time to do that. We could like put these together, but I'm just not going to do that yet. So Yeah, so I just copy this down. 5, 7 plus 13 squared over 7 squared times 4. So if we were continuing to try to solve for x, what would we do next?
We would,
Try to handle that guy, right?
yeah, we would do that and then subtract whatever it's not x, right?
What, this part?
Yeah.
Yeah, but just one step at a time. How do we get rid of it?
Yeah, we would do that. Oh, a square root.
That's right. And so we got to do this. And what else?
The other side.
That's right. And when we take the square root, we could get a positive or a negative value for that.
Yeah.
By the way, I didn't learn this actually until I was at Delphi and the question finally came up. Believe it or not, that indicates positive 3.
Yeah, and if it has an I.
Yeah,
Right?
I'm not talking about imaginary numbers. I'm just saying that the square, if I had x squared equals 9, what two things could x be?
Negative 3.
-3 and 3.
Right. So the answers to this are that. However, when I do this, I actually need to put a plus minus here because that symbol only means the positive root.
Oh.
It's like the tiniest little detail to worry about, but this symbol just indicates the positive root, and then if it's going to be positive or negative, then you use that symbol also. So, and that's why it shows up that way in the quadratic equation. It was like something I had never noticed at all ever before. Okay, good. So that takes care of these things. X plus this plus minus. Okay, so there's one last step till we've actually solved for x. It's really simple. What do we do?
Minus 13 over 10 times 2.
Beautiful. So I'm going to go back to the top. And that's going to be x plus 13 over, actually, let me just take some time here. So minus 13 over 7 times 2, and we'll do it this way, minus 13 over 7 times 2 plus minus that. That works, right? So that equals minus 13 over 7 times 2 plus minus the square root of negative 5 over 7 plus 13 squared over 7 squared times 4. So you may sort of see some of the quadratic formula now.
Yeah.
This kind of looks like it, right?
Yeah.
But it's really unsimplified. So the next thing we're going to do is simplify it all. So I'll go ahead and wipe this out. Now, what do you think we'd do first to simplify it? It's tricky.
No idea.
Okay. We'd add these fractions. This is definitely one of the trickier little steps in this thing. What do I need to do to add those fractions?
With the same denominator.
Yeah, that's right. So let me just sort of write it bigger over here. Minus 5 over 7 plus 13 squared over 7 squared times 4. What's the common denominator going to be?
7.
Nope. You kind of have to go up to a denominator, right? We can't, like, cut this stuff off.
Because 7 is 49 times 4.
Right, that's what I have over here. Like, let's just think about if I had 1/2 plus 5/6, what would I do?
Oh, you would times that side by 3.
Right, 3 over 3, right?
Yeah.
Again, the reason we can do this is this just has a value of 1.
So you have to times, it's 7 by 7.
Good, I gotta multiply this by 7. I'm not quite done.
Because it's also times 4.
Right.
Okay, yeah.
Pretty complicated, right? But anyway, that's just what it takes to bring the 7 up to this. It'll be 7 squared times 4 now. So on top, we're going to have minus 4. I'm just moving the minus to the front. Times 7 times 5. And I'm ready to make it all one fraction. That seem right? Cool. So we're going to put that in the place of this. I'm just going to use, if this was on paper, I'd have to just rewrite it all, but I'll save a little time. You guys keeping up in your notes there?
Yeah.
All right. Really?
No, I'm not. I
Yeah.
totally
I
forgot.
did.
Okay.
Kind of.
That's really good.
I didn't write that thing.
Okay. Well, now the next thing that we use is a rule that often gets forgot about this point in our algebra. It's this idea that this is the same as this.
Yeah.
So that can be applied to this thing right here. So I'm just going to apply that. That's simple, right? I just broke that radical square root symbol. That's all I did. Now this actually is pretty simple. The square root of this, this goes with the rule of if they're multiplied, you can split it like this. It doesn't work if they're added, but for multiplication, this works.
Okay.
So we're going to apply that to this little guy right here. Okay, what's the square root of 7 squared?
7.
Good. What's the square root of 4?
2.
Good. So I'm going to just... Now isn't that nice?
Yeah.
We already have common denominators. So really the last thing is just writing this as one. Oh. Oh, I'm going to do commutative property on these and just put the 13 first because that's how we usually write the quadratic formula. And I'm going to do commutative on this also. So minus b plus minus the square root of b squared minus 4ac all over 2a.
Oh, wow.
If you look at what we just really did, we just took...
That's so
It
cool.
just all
Yeah.
came together.
That's awesome.
Yeah, cool. So the original thing was this.
Yeah, I just kind of like.
It's that, right?
Yeah.
What we just did in all those steps was we solved that for x and simplified.
Yeah.
That's all we did. The whole completing the square bit is tricky, but that's the only way to get an x squared and an x together. If we
Yeah.
just tried to divide by x, then we'd end up with crazy stuff
Yeah.
going on all the time. We'd have 5 over x, and it would never solve. The completing the square step is the thing that lets us get the x in one place. like this. And so what you guys should do, and anybody I have watched this video, you should do this until you can actually just go right through it without looking back.
Yeah.
That might take 2 or 3 times, but it really is, what I've seen is a point where a lot of basics all firm up for you, like you get it.
Yeah.
And then once you can do this whole problem without looking back, then you do it with the letters. You know, you just do it again, one or
Oh,
two.
you have to do it
That's
with
the
the
second
letters?
time.
Letters.
Right, that's problem 47.
Yeah.
If you do that. So, this is one thing I went, at first I didn't used to think this was important to anyone.
Yeah.
And I was like, okay, I'll just help you through it and you'll be through it. And then I realized if you really get this, there's like a big certainty and you feel really ready to move forward with Algebra 2 from here. So, there you go.
Okay. Thank you.
Yep.